Hi everyone, thank you for coming. My name is Quentin ADAM. I'm the CEO of a company called Clever Cloud. It's a pretty interesting company because my day-to-day job is basically to make all application working, because Clever Cloud is a product who keeps your app online. So you just push your apps on top of Clever Cloud and we update it. We allow it's running. If it fails, we rebuild it. We scale up and down the resources. So basically, you have nothing to do for have your application working. What is very interesting about that is we learn a lot of how developer works, what is working, what is not working, and things like that, because we see hundreds and thousands of applications deploying on top of the Clever Cloud, and hundreds of thousands of developers from big company to small startups using it. And we learn about good or bad design, and we try to get back to the community as much as we can with blog posts or talks. So why we will be talking about protocol. Protocol is something interesting in this world, because existing protocol are not good enough. If you think about it, TCP protocol, TCP IP, has been made in the 70s. So it's something very old. And we build around all the protocol and all the system around there, because there is something interesting in the computer world is we like all layers. And all layers are just stacked together to bring new things to the application. So if you're thinking about all the OSI layer built from the whole model, right now what we do is API on top of HTTP with JSON. And it's just something like a new layer on top of the USI system. And the problem with that is it's the generation. Each time we build into the computer world a new thing, there is plenty of space in front of the room. Each time we build new things in the computer world, we build it on top of existing code, protocols, and things like that. Whoever built a TCP stack in this room? Yeah, that's right. Nobody built this, because we rely on the underlying layer. So think about it. What will be enabling in 20 years when people starting to build on top of something built on top on JSON plus HTTP? So this is the problem we want to speak about this morning. Our needs are very changing right now. There is a lot of proxying and the mobile stuff, because if you think about it, HTTP world is not made for the mobile. The mobile is something very light, it's embedded. We have a lot of problem of electricity because we don't have enough power to load a lot of things, and we need a lot of things like that. There is something interesting about it. It's called push. Everyone has things called push notification inside this. And push notification are just basically TCP long-term connection, but only with server of big company like Google and Apple. But there is new thing about that. We need the push for a device which is not connected to a network, but on the air. We need a lot of things for the Internet of Things, and it's a embedded world. Do you know how expensive is a TCP stack? It's something very heavy, so sometimes you don't want to put it in your embedded world where you have limited resources and power. Did you know about a company in France, quite interesting, called I cannot remember. It's a very interesting company who provide just a small piece of data, just 1 or 2 kilobytes, but it's a very few power conservative, so you can be connected for years with it. And this is quite interesting. And now we have more and more data. Data is about to be something very impressive in a few years. Just thinking about it, terabytes of video right now on a laptop. How to manage that in your network cards? Because we manage more and more data from an external resources than just your computer. So now more of the data you have reading in your computer are just pushed away. So this is very changing needs. Just try an example with P2P and WebRTC. And you are in the WebRTC world. Who is doing WebRTC in the room? Okay. So basically, this is how it works. We need to bring a connection directly from a browser to another browser. Okay? Right. The two browsers are behind NAT networking system. So they can't talk to each other because there are no public IP address. How we can do that? It's not a problem. We will bring with a server in the middle, and the first browser is going to the server and say, okay, I want to speak with the other browser, but I cannot know how I can do that. So I guess my network data port on the output will be that. What's the one I want to communicate with, and the other brother does the browser does the other things, the same things, and we exchange the maybe I guess out data port of each on the NAT network, and then connect it together, saying, okay, now you have a stable TCP connection. Do you realize how crap is it? It's something like, okay, we will manage it to make this happening in the right way. But in fact, we are just handling a lot of hacks on top of HTTP and TCP. The other thing is you say, we already saw this. We will use everywhere HTTP and things like that because it's working right now. Yeah, sure, it can be working. Why not use REST and JSON API on top of HTTP? Okay, there are a few things. It's not a good idea because REST is for resources access. It's not made for RPC call because in majority of the time when you're doing that, you are handling action. Just thinking about that. I made a REST application API to power on a coffee machine. A coffee machine can be powering on, like, is it a resources? So basically, you are hacking REST. The thing is, JSON has been there around because we don't like XML. Because JSON is a good excuse for saying, okay, I have no format, so what I will be doing is just using my JSON to manage the data with no format. And HTTP is not made for asynchronous communication. Just think about how we can make a lot of hacks using HTTP for using WebSocket. We are looking at WebSocket in the room. Okay. Do you feel the pain of using WebSocket with HTTP? We understand it's not made for this. So it's complicated to using this kind of thing because HTTP is, I ask something, okay, this is the answer. And it's not made for anything else because HTTP is made for resources. And how we can handling RPC error with HTTP error? Because an error in RPC is about something is bad happening during I execute the code you ask me to execute. So it's not the same thing. We have to make thing between resources and RCP. Resources is something like, I want some information in this kind of representation. And it's a picture, it's a book. A resources is not something like, do something with that. Do something, it's something we call remote procedure call, RPC, yeah. It's wrong for me. Remote procedure call is something like, I want you to make new code executing on the server. And it's not the same thing, you know. So this is why it can be wrong to using a resources grammarian instead of saying something about remote procedure call. If you're thinking about it, it was what we built with SOAP. We're using SOAP there once with WSDL. What was interesting with SOAP and WSDL is you have a format saying, okay, this is all will work, all the thing about my program on top of the servers. And the WSDL saying, I have a method taking this kind of parameter. This is the schema of the parameter, and it will take this kind of time, and I will return this kind of parameter, and this is the schema of this type of parameter. So basically, when you're calling a SOAP, you have all the information inside the WSDL to say, okay, it's very simple to understand how it's working in the service. So basically, you can just take the WSDL and put it in a program which will generate to you the code of handling the SOAP services. This was quite interesting because you can execute a service using the WSDL generating the client on the SOAP service during the runtime. So you haven't to be there to just fix the thing together, because all the knowledge of always working remote procedure call on the server was just built in the format. That was a great idea. The bad idea about SOAP was it was just really heavy, a lot of XMLs, a lot was just increasing, and nobody understand why it can be interesting. But the basic idea was not bad, it was interesting if you're using properly, because sometimes you have problems. I remember once I was working on a project with a company providing SOAP services, and they provide the SOAP services code with .NET 1 on top of a Windows Millennium server. So basically, I don't get why they put a Windows Millennium server in production. It was just like 4 years ago. It was not like something old. And they say to me, no, there is no documentation because the SOAP system is self-documented. Oh, well, right. Thank you. And I opened the WSDL. So basically, yeah, there was name of the method. The first method was called method 1 and takes parameter 1 and parameter 2. The second method was called method 2 and takes parameter 1 and parameter 2 and parameter 3. It was like, guys, are you serious? Basically, I tried for 2 days to send like something in the method and see what's going on. And I will figure out how to manage a SOAP at the end of the day. So this is the kind of usage you don't want with SOAP. But what is interesting with SOAP is creating an administrative console from a SOAP web service is so easy and so quick. It can be done in just a few lines of code because there is a lot of generation around it. So it not be a good idea to expose it to all the world, but it can be a very good idea to expose it in the internal of your company to manage this kind of thing with it. It's very simple in Java EE to manage a SOAP and a REST API together in the same system. because all is made by annotation. So maybe it can be interesting for you to try this around. Another thing interesting is now with REST system, we have two kind of files quite interesting to describe what is your API. There is one called WADL, and the other one is a Swagger file. Swagger file is going to be big because it describes of your API and allow you to generate some client of code for your API. So basically, this is that. So why build your own protocol? Nobody wants to build their own protocol. It's very fun to do, but nobody wants to take the time for this. So think about this and let's try around. The first thing is you can manage synchronous and asynchronous data when you're building your own protocol. So basically, it's quite interesting to say, my need is asynchronous or my need is synchronous. So you can make the boundaries of what you really need to do inside your protocol. Think about many times you have to make many requests to the same thing and bundling them together in the server side and cause problem of the acidity of your data, because the protocol is not made for transactional. You cannot make transaction with HTTP. If you're building your own protocol together, you can make transaction saying, okay, this is a transaction, it starts there and it finishes now, but you can bring a lot of things inside it. The streaming thing. Streaming will be bigger and bigger. We have heard about Kafka, Twitter Aaron. You have to look at Twitter Aaron. And all this kind of Spark. All this kind of API are based on streaming. Streaming is something very big now inside the developer community, because we are handling a lot of data and we need to match like real-time treatment and not batch. If you're looking at the data with batch, it's okay if you have just a little few of data. But if we want to interact with real time with your users and interact with a huge quantity of data, you have to manage the data in a streaming process. In the Java 8 is bundled with something called reactive streams. And reactive streams is basically very interesting for that, because you can manage streams with like something like Aka streams is something you can say, okay, I have data streaming from there, then I put it inside a streaming processor called a flow, and you just drawing an arrow between the data resource and the flow will be built in this another flow, and we can split the flow there, and I output the data inside this on this. It can be WebSocket, another database, an enterprise service bus. It's not a problem. You can do all this thing with streaming system like Aka Stream. It's powerful and you have to link with this kind of thing. And it needs new protocol. This is basically why Kafka has its own protocol. This is why RabbitMQ with all the IMQ-based stuff are new protocol, because it's based on streaming needs. You need to be sure of guarantee of delivery or not. Basically, each time of you are maybe using TCP because, oh, we all use TCP. Just thinking about that. If you're pushing live video from a conference, for example, you want to grab the video from there and live it in another room, and you want it be live. You don't need guarantee of delivering. If you're losing a packet in the meantime, you don't need it. What you want is live. So it's a new packet with a new pack of the video. You don't need the previous packet. It's old. You don't want it. So all it can be is not guaranteeing delivery, which is really great, because hack on all the packet takes a long time. Last year, I was working on a project for Roland Garros, you know, the tennis contest. And the project was pretty cool. In fact, we have an 80 square feet screen, and people playing in Pong at this screen. And the Pong game was playing with a small distance detector, so people are playing like this to manage the Pong. I don't know how to say and people are playing like this. And we were streaming all the data of the distance between the hand of the detector with this. And at the beginning of the contest, we built something around TCP because we all use TCP. When you are in the network infrastructure of Roland Garros, there is plenty of data. And all the data with high priority is the video of the current match. So your data is not priority. And what's happening to our TCP packet is, they were in the computer pretty fast, but the ACK system was so slow that it was practically impossible to play, because the ACK takes too much time. We rewrite it using ODP, because basically, if something at the hand there, then the hand there, what you need to know is the hand is there now. The hand was there before. It's not irrelevant information. So we rebuilt it all around UDP, and the game was pretty cool. So this is why you need to think each time you are forwarding data from one point to another point. Is it relevant to guarantee the data delivery or not? Maybe it's not. And there is kind of different network topology, like the bus, the star. I really like the ring stuff because it was just like so cool to see all is getting around. Okay, I wait for the token to speak. It was a really cool network topology. Why I speak to you about network topology, because you can say to me, okay, we all have Ethernet, TCP/IP, so the thing is done. No, it's not. Because of this and of many other devices which is not connected physically to the network, but basically around in the air. So there is plenty of new network infrastructure like NFC, Bluetooth Low Energy, and plenty of things like peer-to-peer network. There is interesting thing about robots who think together as an entity, and they connected with peer-to-peer system with each other from thousands of miles to be at the internet at the hand. So basically, it's no kind of network topology to allow you to get a lot of paths in the network to bring your data. So maybe your protocol has to handling the way of split the data and bring them together. I have an interesting thing called the Erasure cache, the Erasure code. The Erasure code is a way you can take the data, split the data in several parts, and send the different parts in many ways. And the thing is, if you get only 2/3 of the data, you can put it together and have the original data. But what is interesting, if you're building something like communication system for military in operation field, it's quite important, because if you are in a place and there is plenty of relay, but you cannot be sure nobody is looking at the relay to get your data back, it can be really interesting to base your protocol on something like erasure code, because the data splitted and they can grab a piece of the data is not usable. What they need is the totality of the data or part of the totality of the data to bring them together and have the information system. And this is kind of thing with network topology inside the protocol, which is very, very exciting, because it can bring new usage to the Internet of Objects or something like that. It can be also for the embedded. Embedded is right now the most exciting thing inside what we do, because embedded is all the Internet of Objects, is the robotic, it's all the thing we need to do with a computer right now. And the other thing is built over a communication channel. Was doing Bluetooth something before? Okay, did you find this easy? Yeah, because Bluetooth is totally another thing that what we do with TCP/IP. Few months ago, I was on a project, and we're building things with Bluetooth Low Energy. And we're sending JSON on top of Bluetooth Low Energize. And the problem is you cannot guarantee packet delivery. Okay, you cannot guarantee packet order. So basically, the overhead of building a protocol around JSON was so big that we tried to build all the thing with just small packet to be able to send the information in just only one packet without guarantee of delivering. Because if we put all the thing inside of the JSON message split in several packets, each time we have a marshalling problem, because we cannot be sure of the order of what we do and things like that. So we build inside the packet new thing like, this is the order of the packet, this is the thing, can I have an ASIC for this packet? So we use EV connection between the two devices, and it slows down the battery of the system. This is why we need to build something on top of just one packet without guarantee of delivery and think, okay, it will be cool if it's delivered. But if it's not, oh, no problem. We can resend the data in another way. So this is why it can be interesting, because Bluetooth communication channel is something very simple to use. You need to try Bluetooth kind of communication channel. It will change totally your vision of the world, because you realize that the link between the two parts of the communication is not that reliable. And it's what's happening now in our device, because more and more we are device without physical connection, so it's not reliable to connect them. Okay, it can be very hard to build your own protocol, because every communication is a protocol. What I want to speak with you with this talk is, if you're thinking about every communication like a protocol, you can use all the protocol strategy, all the paper right on it, to think about your protocol. And every communication is a protocol. It will be formal or not. It's not because you haven't write a formal description of your protocol, it's not happening. It's just like you let the nature decide, and I'm not sure it's what you want to do. Because if you describe properly the protocol, first you can create a piece of code which generates the source code, and then you haven't to speak with the people we're working on the other side, because it's written and it's described. The interoperability is something quite important when you're speaking about protocol, because the interoperability is how you manage to be able to be sure of one side and another side is able to communicate within the time. And if you're thinking about the ambiguity, because people are thinking, if I'm not describing this, I let the people free so that it's good. But it's not. Because the ambiguity calls a little deviation of the thing. Because all the people are making their own interpretation of what we describe. So if you're making a lot of ambiguity between the two, it will break the local protocol system, because all the people will do different things. So when you say something on terms of protocol, in terms of API, don't be ambiguous. You have to be strict, because this is all it's working. The other thing about it, it's how you can try and test the thing. The thing is, testing is quite important. A lot of APIs these days are no test, because it's impossible to test. When you write something, you have to think about how I can try and make like impossible to break test about this. If you can make test, you can rewrite all the same, put the same test on top of it. If you can test it, you can be sure there is no regression in the code for years. Think about all the problem we have with OpenSSL. All the SSL layers have the problem of the test because there is a lack of system about that. And that is why people are getting so hungry about tests right now. If you're thinking about what is a protocol, a protocol is a state machine. A state machine is something like you have a state, then a transition to another state. If you're doing your code right, you can describe the transition between the state and be sure you cannot break to a transition within 2 points. Because if a transition between two states don't have to exist, you have to put something to don't all this. This is basically the kind of problem you can have with a lot of implementation of security because there is steps. And if I send a packet saying, okay, I'm now in step 6, the system is in step 6. But in fact, there is no transition between step 1 and step 6. And you have to break before saying, okay, it can be in step 6. So when you write this kind of thing, just thinking about being a state machine. And how to encode this inside a system, because a lot of people are thinking right now there is a pretty good idea which is using text protocol instead of binary protocol. If you think about it, it's a really bad idea because text protocol are handling a lot of problems. We have one day work with multi-part data, multi-part HTTP data. You have a look at what is going around. It's crappy because it's quite complicated to define the boundaries. And when you're trying this kind of thing, you are just pushing the limit of text protocol. If you're looking at binary protocol, it can be more simple, more compact, and more interesting things to do. So basically, binary is cool. The reason why developers don't like binary protocol is because they cannot read it in the command line. Yeah, sure. But we all have Wireshark in our computer, no? Who have Wireshark set up in his computer? Okay. This is the way you have to deal, because you cannot guess what is happening on the network card. Wireshark allows you to check all is going around with your protocol. So basically, you have to use it like every time when you developer, instead of putting some weird thing in the JavaScript console in your browser. In fact, developer adds a state machine because they are afraid of it, because it's something they haven't written from decades. Who have written a state machine this last year? Cool. If you're thinking about it, a state machine is something quiet because it closes a system, so you know the boundaries of your system, so you are in a something like easy to make trends. If you're building a state machine, what is important about it is how to be able to manage the way the whole transition happening. So there is 2 ways. The first way is to making this kind of schema. It's kind of complicated to implement, but it's very readable as to close state of the system. What is important about that is you have a clear definition of what you do, but it can be quite complicated to do. If you're thinking about that, we have no really big type language, like for example Rust. Geoffrey Coupry, who brings this presentation up at the beginning, I've written something quite interesting in Rust. If you're describing your protocol and the state machine of your protocol inside a Rust type system, you can say, okay, if you transition to state 1 to state 3 and there is no transition existing with this 2 kind of thing, what is going is the code doesn't compile because it's statically check with the state machine is quite good. And this is, in my guess, the good way to do this. But people like every time doing this kind of thing, like a big switch between all the things, saying, oh, the packet say packet 3, oh, no problem, I will doing this this way. And this is the bad approach, because you need to have a clearly understandable of all the transitional state. So this is why it can be cool to rely on a strong type system to manage it. If you're building a type machine, what can be interesting is you know all the boundaries. So if you know all the boundaries in the state machine, you can have bugs. The other thing is you can parse it with two ways. There is two ways to make parsers. The first way is the data size, saying, okay, I have 500 bytes of data, and the next 100 bytes of data will be there. And you say, what will be the next 500 bytes of data? It's working very well. It's like this, like major of the early protocol was right, saying, okay, for the next length of data, I will be doing that. The problem with that, if you have to be able to calibrate that your data will be handling in the good way. You have to be sure and guarantee of delivery of whatever the size is. And you have to be sure of your implementation. Majority of the case of the problem with OpenSSL are typically this kind of thing. I think I have data for this, and I sending lesser data, and then grab all the data around. It's basically how works ElseBleed, and it's based on this kind of thing. And the other way is create boundaries. So create things them to say, okay, I have this kind of data, then I have this kind of data, then. And create window of data inside your connection flux. There is few ways to path the thing like that. The first way is to say, okay, I will use regular expression like in Perl. Who is doing a lot of regular expression? Okay, this kind of thing is quite complicated. Who is able to parse like HTML with regular expression? It's quite complicated to do. In fact, you cannot do that because it's so complicated. You have a lot of risk to cannot be there. So you have to put on the context-free system. The context-free system is able to say, okay, I will parse this kind of thing like right there. And what is really important is to say, okay, we have context-free and context-sensitive thing. So maybe the data have a context, which is quite dangerous because you have to handle stateful system inside your thing. So it works on memory and things like that. And at the end, you have like basically a programmation language because you have Interoperability. The thing is, if you're not doing attention and pay attention on this, you can have like weird state machine. Weird state machine is a case when you put some data inside it. It will work or not, and the problem is maybe there is some code it can be executing. It's basically all the problem you can have with parsing of file, like big binary files like .doc or movie file, who are able to execute code inside VLC or Microsoft Word because the parsing was not really enough and was too complicated to be completed. Because the grammar was not cool. I was talking to describe clearly the protocol just before. This is an ABNF grammar of, I don't know what is it, but what is important with this is we have a clear reference on how is it working because we know it's clearly described. And if you can summarize all the grammar of your protocol in a schema of grammar, it can be working. Because Parser generator can work on this. ABNF can be a good describer of what you do. If you cannot fit your protocol inside the RBNF descriptor, it seems it's too complicated. And if you have something clear about your grammar, you can be using Inteler, for example, project, who just building your code of handling your parser. So it generates a code. It's too simple because all the world is working with C code. It's too complicated. But this kind can be impressive. It's in Java. You have to look at this. It's quite impressive to be on your protocol and just generate the code source of handling it. And the other way is to build Parser combinator. Parser combinator is something very, very simple. Basically, you say, I have a function handling just this. And I have another function saying handling just this. And I combine all the functions together in a one big function to manage it. So basically, I have some small function working together, which is very interesting. And this is the way you have to think, because now in Java 8, you have the Lambda system. Managing small piece of code working together, it's so cool because you know the boundaries of your function. It's so simple. So Parser combinator is how it's working right now. And all is based on your code architecture, because all the code architecture is important on this. Because all the code architecture, as I say, the boundaries of the code are so simple to manage, so there will be no problem around that. You have to parse at the beginning of your program and validate at the beginning of the program before starting to do something with it, and validate more early you will validate, less problem you will have later. Because when you're just unmarshalling your data, the data can be just like unsafe. And if you're starting to act on your data, maybe you will execute some code you want to execute. Think about that. It's very important. I have plenty of examples. Like for example, there is a Java, the Apache model, able to split the write between many virtual hosts. But the problem is the parsing is made by root, and then you find the virtual host and switch back to a lesser write elevated thing in the Unix. It's too bad because the risk is on the parsing. So maybe it will break just long before you are in the thing. So just parse early and validate early. This is why some kind of new things are happening in the network stack. Now there is people working on network stack in userland because they want to say to the network board, just bring me the data, I will handling it, without to use the huge pack of code of the kernel. I don't know how is it working. So new userland stack of networking can be very interesting on this kind of thing, because they just grab the data and managing it inside the userland. The second thing about that is you have to manage about the versioning, because every time you made a protocol, you have to version the protocol. And the versioning of the protocol is something you have to handling with, for example, version number. This is the basically simple way to say, I have in version 1, version 2, version 3, version 4. If I don't get what is the version number of this, I just say I cannot handling it. It's a basic thing you have to do. If you not introduce a version number of a protocol, it can be complicated. Then I can do something very far better. It's called a negotiation. Hi, I'm the client. I'm going to speak with you, servers. I can manage version 2 and 3 of the protocol. And the server say back, okay, I can manage version 3 or 4. Let's talk with version 3. This is quite important to understand how to negotiate vision of the protocol negotiation. If you're looking on all the TLS SSL world of the HTTPS sys, there is plenty of negotiation. Developer just forget about it, because there is a negotiation of the version of TLS we will use. Sure, but there is also the negotiation of the algorithm we will use to negotiate the thing. The algorithm we will use is something like, okay, I want to speak with RS, I want to speak with, and there is thousands of algorithm. And what is going around is sometimes the TLS version is good, but the protocol, the algorithm of encryption is break. So you have to deactivate in your server the way to use this kind of encryption level because the algorithm is breaking. And you need to negotiate with this with the clients. And this is one of the best things happening in this thing, because you need to be able to say, okay, we will not using this algorithm no more. And this is quite important to understand. I will speak further about that in a talk about HTTP2. I think it's tomorrow I talk about managing HTTP2, and I have a lot of things to say about that. Then there is Schema repository. So how is it working? I don't know if you heard about what is Avro, a very well-known protocol of the Apache Foundation with all this kind of thing. And this is a kind of thing you can say, okay, this is a schema of how we will exchange the data. This is how the data has to be exchanged. So this is quite important things to think. And the error management has to be built in the core of the protocol. You cannot just, when you're doing an API, saying, oh, if that's working, no, too bad, I will return 500 error. HTTP is extendable, so build your own error code and document it and return something with a text you can put in front of the user or something like it. Just extend HTTP to error management in the right way what you do, because what is important is error management has to be handling in automatic way. And if all the error are just 500, it cannot be done by the code to manage your error. All the error has to be pretty well managed. I remember the time of the Facebook API. They're making an API with all the error management, was just 500, no error code inside the answer, but only a string. And the string, for the same error, changed maybe 4 or 5 times in 3 months. So basically, all the error system we built around that was just breaking without no knowledge, because Facebook decided, okay, we will change the string. But why do you put a string? Just give us an error code saying this is breaking. And this can be interesting to be there. You have to think the error management not like a developer thinking, oh, this is a bad way, this is what's happening. But in a program and the software thinking, this is a bad way, and there is how I will manage it. And thinking about making them readable for a software. And the authentication and the session are quite interesting right now, because we all know login and password cannot be the ultimate solution to authenticate all what we do. How basically we can authenticate each other with certificate, or maybe with a USB key, with a fingerprint, there is a lot of things about authentication we need to bring, and the session is quite important too. Session poisoning is the best thing you can do for hack something, because people don't care about is managing the session system security. Who is using the security system of this framework without read the code we handling it? You all read the code of the framework about session security? This is the point. People don't read the code of the framework. So you have to get how is it working to manage it the right way. I talked about that before, but you can read the joke. It's a funny joke. And I have speak of token separation and long field just before. And just thinking about the layering. If your protocol are too complex and you cannot modelize it, it's because you are handling something of the upper layer. So basically, just split your system in several layers to be able to manage it the right way. The toolbox. You have to think your API as a protocol. API as a protocol is something interesting because you will not break it. Thinking about this, how to manage upper version of your API in a long term. Thinking about what is happening to the Twitter API when it comes to the V2. Plenty of library just dying. Plenty of software just dying because it was too complex and they aren't a good way to manage the transition. And this is quite important. Think your API as a protocol to make whole your ecosystem survive. You can also think your code as a protocol. There is something I was finding fun in Objective-C system. I'm not a big fan of Objective-C, but one thing I called cool was all the system of interface was called protocol. Because basically it's a thing. You are passing data from one point to another when you are doing your code. So basically it's an internal protocol. So think about your code as a protocol. If you have a large code base and if you are if you are a builder of library for others. Review the state machine course. It can be useful. And you have to make some experiments because protocol has to be made by experiments. Today, it's simple to do something on just a TCP socket. Node.js allows you to doing this like very easily. You can do that with some of the coolest network stack on the JVM, like Netty, and try to understand how to managing all other stacks than just HTTP. It can be very interesting. So thank you very much for listening. This talk was made before by Geoffrey Kupri, who were working with me. I'm so sorry he cannot be there, but his sister is just like thick, so he have to be there. And I'm thanking for all the advice, and it's a real pleasure to work with Gel in all the way. And this is some note you have to think about that. So thank you very much for listening. And I think we have the time for one question. Question? No question? Okay. Thank you very much.